All right, asymptotes. That's pretty much what I think the title of this section should be. But we're going to start by looking at the graph of this guy. If we were to graph this, where would you start? I'm hoping that you guys, making a table of values, you would start with just plugging in some random numbers. Like if you plug in -2, -1, 0, 1, and 2, at least starting with that, and then figuring out what you would get when you plug those in. When I plug these in, let's see, the first one I would get a -1/2, and this I would get a -1. If I plug a 0 in, I get undefined, because you can't have a 0 on the bottom of a fraction, and that's actually huge. That's a huge concept right there. You can't have a 0 on the bottom of a fraction, so we can't plug in 0. It's undefined. Can't do it. If we plug in 1, we get +1. We plug in 2, we get 1/2. When I graph this, it looks something like these. Let's see. We have -2 goes down to 1/2, -1/2. So it goes right about there. -1 goes down to -1, and then 1 goes to 1, and 2 goes to 1/2. Now this is kind of weird. How does your graph look right now? Now because I've seen rationals a lot, I have an idea what this graph looks like. But right now, looking at these points, I have no idea. There's no clue right here that tells me what this graph is going to start looking like. So I'm going to pick some more x values. Let's see, I picked -1 and 2. Let's pick -3 and -4, and we'll go the other way too. We'll pick 3 and 4 on this way too. So we pick -3 and -4, +3 and +4. And when I plug those ones in, I get -1/3 and -1/4, +1/3 and +1/4, which actually doesn't really help me out that much. It just shows me the points right here just keep getting closer to the x-axis. -3 goes to -1/3, -4 goes to -1/4, and then going the other way, it's 1/3 and then 1/4. And so I guess we kind of have an idea. I mean, what does the line do? Does it go like this and then go, what does this line do? I don't know. Let's try something kind of different. Now this, you probably wouldn't have tried this unless you're one of those calculators that figures things out. Like some people might have looked at this and went, what can I plug into that x right there that will give me a different number? Like I want a number that's bigger than 1. What can I plug in right there? Yeah, you could plug in something like a 1/2. If I plug in 1/2 and a -1/2, what would I get? Well, it would look like this. If I take this function, I plug in 1/2, it would be 1 divided by 1/2, which looks kind of ugly, but when you actually say it and rewrite it, it's different. 1 divided by 1/2, so it'd be 1 divided by 1/2. What would that equal? Well, that'd be the same as 1 times 2 over 1, right? And what's 1 times 2 over 1? 2. So finally got a number bigger than 1 and smaller than -1. And when I go to -1/2, which is right here, I go down to -2. Sweet. If I go to +1/2, which is right there, I go up to +2. So now we have a better picture of what both of these lines look like. If we picked a smaller number, let's pick 1/3 and -1/3. What are we going to get if we plug in 1/3? Yeah, that'll be a 3, and this will be a -3, right? So if I go to 1/3, which is a little closer to the y-axis, it would be right about there at -3, and that would be right about there at +3. And so we can see where our lines are going. In fact, when you guys graph these, they look like this. Oops, that messed up. I was doing so good. Oh, dang. I love my undo button. It's so nice. And then this one looks something like this. It goes down. Okay, this is a rational function. This is a graph of a rational function. This is what it looks like. Now, because of this spot right here, 0, because I cannot plug in 0, this line cannot cross where the 0 is. It just keeps going down, 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 and it'll never, ever, ever, ever cross this line right here, this y-axis, because it says right here, 0 is undefined. And when x equals 0, you're on the y-axis. And so that's where we come into what an asymptote actually is. So what can x not be? It can't be 0. How does this affect the graph? Well, it will never go through that line right there. And so what we normally do is we put a dotted line where we have our asymptote. Now that is the vertical asymptote. I'm going to say VA for vertical asymptote. And in this case, our vertical asymptote is x equals 0. There's another asymptote on this graph. Do you guys see it? Do you guys see these lines right here? How they're not crossing the x-axis? That's another asymptote. That's called the horizontal asymptote. We'll call him the HA. And in this case, our horizontal asymptote is y equals 0. Now, not all rational functions have horizontal asymptotes, and not all rational functions have vertical asymptotes. But we do have a method of figuring out, if a rational function has one of those. So just for fun, just so you guys can see like how this changes, let's take this function and change a little bit. So we have a g of x, and then we have 1 over x plus 1. Okay, here's a rational function that I changed just slightly. I added a 1 to the denominator. So what can x not equal here? It cannot equal -1. And so that means our vertical asymptote, this guy right here, is going to change. It's going to be right here on the -1. And that's going to move, it's going to shift our whole graph over to the left. Now this is in your book. It's a lot of stuff in one thing, and when you get good at reading math textbooks, you can read this. This says on the top there's a polynomial, on the bottom there's a polynomial. The most important thing to note is the top polynomial right here in the numerator, the n is your degree. The n is the top degree, okay? The m is your bottom degree. Those are the highest exponents right here, the n and the m. And then when we go to start reading this stuff, it makes more sense. Now the first one says the graph of f has vertical asymptotes at the zeros of the bottom one, of the bottom polynomial. So all that's saying is, what can x not equal? Those are your vertical asymptotes. And so this tells you how to find your vertical asymptotes. Quite simple, because we've been working on that. We've been working on finding zeros already. The one that's a little more complicated are the horizontal asymptotes. So that's the one I want to talk about for a second. To find horizontal asymptotes, we have a couple cases. We have 3. 1, 2, 3. And these are our cases. The first one is this one right here. It says when n is less than m. What does that mean? When n is less than m. That means when the degree on the top is smaller than the degree on the bottom. So when n is smaller than m. The graph of f has a line y equals 0 as a horizontal asymptote. Oh, cool. So that means whenever the degree on top is smaller than the degree on the bottom, this is your asymptote. You don't have to do anything else. That's your asymptote. It changes when we get to this one. If they have equal degrees, to find your horizontal asymptote, you have to take a sub n and divide it by b sub m. Those are your 2 leading coefficients. And I'm going to show you guys examples of this. One example of this one right after this slide. And this last one right here, if the top one has a higher degree than the bottom one, if the top degree is bigger than the bottom degree, then it has no horizontal asymptote. Okay? So I'm going to save it for our next video. The 2 examples of the last to find horizontal asymptotes.